Hi, my name is Bill Kearns. In this demo, I am demoing Google BigQuery, Google Maps, a console app, and I'm going to talk about data warehousing in general. Here I have a web page I have hosted, voter turnout, and please excuse that it says for development purposes. I don't have a billing account hooked up to the project. But here I have municipalities that I've gotten from census tract shapes and done some aggregation calculations and wired up an on-click event. And you can see that, say, the Dover municipality has a total population of 7,126 with 5,702 voters, and had a total of 7,251 registrations, and that leaves a ratio of 127.17%. So a colleague of mine has gotten a copy of the voter registrations from the Board of Elections from Pennsylvania and has ingested those into Google BigQuery. And I have then ran a console app and ran some queries and performed some sums and then render the data as a map. So here is the BigQuery data schema. Here you can see in my voter analytics project, I have used the public data sets available to everyone, the Census Bureau _US boundaries, and some other metadata that I received from the state. This is not in use for this project. Here is the schema of the Census Bureau, some of it Census Bureau data set, and then the other summed data that I'm using is the NCOA data. So here is a schema of the registration file received from the Board of Elections, and we have paid a service, NCOA, to geocode the addresses that's available to the public. Any member of the public can purchase a copy of the voter registration file to see who's registered to vote in the state or their county and which party they're registered with. And here you can see a latitude and longitude. So we basically have an XY coordinate for every address from the voter registration file. So from there, I'm calling, I had to write a console app. It's a really simple .NET Core console app, and here I'm connecting using the BigQuery API client libraries. I connect to my project. I've hooked up the authentication and key and everything so that I can use the BigQuery APIs more or less as a driver and run RESTful web calls. It's really easy to use. So here I've made a list of tuples for every county with the county name and the county FIPS code. And the flow of this is very simple, which, by the way, this would be multi-threaded, but Google BigQuery does not support threaded transactions. I think it's great for a public-facing data source to expose a lot of data to the public or for a website and then abstract your internal data sets. I wouldn't use it for internal data set processing regularly. So here I have a for each loop. I go over all my tuples and I run a simple query, select all the LSAD names from the census tract data that are within a county. So then within that, I loop through that, I run that query, and then I loop through that query's results, and then I call and invoke my stored procedure. So here is my stored procedure that stores aggregated totals. Select voter analytics by registration per census ratio, and I'm passing in the LSAD name, which is basically a unique census tract name, the county name, and the county FIPS code. Well, it's really the county FIPS code and the LSAD name make a unique combination. So here in the query, the outermost part of the query, for the cadence of the query, selects calculations, and it looks for the total population minus anyone that's under 18, and that's how I get my eligible voters. And then run some other aggregates, which I'll get to the body of the query. Starts with the census tract, then I interjoin in some nested derived tables. The innermost nested derived table groups by the LSAD name and the county, the precinct ID. So there's many precincts within a municipality. There's many municipalities within a county. So the innermost derived table selects from the NCOA, the voter registration data, joins by ID number, and then I join in the census tract. The census tract has geography shapes, so then I use the stContains function and I look at the census tract geometry, and then I make a geopoint out of the NCOA latitude and longitude that was provided, so I can essentially join in, well, which voter registrations by address that are geocoded are within that census tract. Then I join in some additional census tract metadata tables. So then I set my query criteria, my where clauses, where the voters are active, and then parse the parameters that I had passed in. And then in the innermost query, I select a count. So I'm really grouping out, well, what count of people within this census tract, within this county, uniquely voted at each precinct. So then, stepping out a level to the outermost derived query, I simply sum that count. And I again join to the census tract data, and then stepping out again to the main level of cadence, I started with the census tract data, and then at the bottom I have an inner join to join back to the NCO data so that I can get additional metadata from the voter files, and I go ahead and group that again by LSA ID and precinct split ID. So I run this big enormous query for the unique combinations, permutations of the counties and then all the census tracts within the counties, and then I insert that into a calculated totals table, voter registration ratio census, voter registration ratios by census. So from there, it takes a few hours to run. The console app will run and finish up and produce some results. Then I can run my web page. So here in my web project, I've written some simple TypeScript. I have an AJAX service that just runs some RESTful operations, which I got right off the internet. It was a quick and easy to use component. And then a simple implementation of the Google Maps TypeScript implementation, imported that to the project, got my map element on my page, my container, and then I run an operation to query the data, which is located in a simple web API implementation here under my controllers. And here's the query, and so I run the query and then massage the data a little bit so that the arrays are full polygon shapes, and then send that back as JSON as polygon shapes. So then I enumerate my results from the query, and I set all my map polygons in the Google Map, and then I've wired up and hooked into the onClick event so that I can have pop-ups of some of the aggregated totals. So, and voila, that is how I have, that I know that, say, Dover County has 127.17% registration rate. A normal registration rate as far as data analysis would be about 45 to 48%. Maybe a little higher, maybe a little lower. That's what I've read. So from there, additionally, I wrote another query to show a weighted rank. So here in Google BigQuery, and just to demonstrate, here I'll run a select star, limit 50, so I'm going to get 50 results from the voter registration ratios by census. And this is just a random 50 results. And you can see for this one, the county is Adams County. The county FIPS code is 001. So this is for census tract 317. Looks like these top 8 rows are for census tract 317. So within census tract 317, we had a total population of 2,627. We had a population of 2,152 people that are over 18 and over. And we had, looks like 8 different precincts people voted at. So 966 people voted at precinct 27-1, 163 people voted at precinct 16-1, 16 people voted at precinct 22-1, and 15 people voted at 32-1, and so on and so forth. So I take the sum of these, the voter registration from snapshot in precinct split, 1, 1, 5, 7, 15, 16, 163, 966, and that gives me a total of, looks like 1,174. So then I take the 2,152 divided by, I take the 1,174 divided by 2,152, and that gives me 54.55% voter registration rate for that census tract. Census tracts uniquely line up with townships and boroughs. So here's also a map of York County. As a matter of fact, these municipalities were affected that had over 100% registration rate, which is technically not possible. It's my hypothesis that some data somewhere was massaged and used with zip codes, because and it's only a hypothesis, zip codes are in lines. So you might have zip code 17104 that's like this, and somehow registrations may have been created that were inclusive of zip codes, where, you know, a lot of times a zip code is close to itself, you know, but you might have, you know, a little piece of a zip code, you know, way out here. It just doesn't make sense. But the sums are there, and you know, those were my findings. As far as data warehousing goes, I would move these queries. Oh, and lastly, before I forget, here is the weighted rank. So I've taken the voter registration from snapshot and precinct split, which is this column, which is grouped by how many people voted at that precinct that are located within that census tract, and then divided it by the census eligible voters, which is this number. And then I multiply that by the voter registration divided by 100, because it was already a ratio, and then I multiply that whole thing by 100. So that gives me a version of a weighted rank. So if I run this query, then I can look statewide at the precincts that were most likely involved in some kind of bad data. So here's, you know, precinct 1881108-1, which is in Allegheny County. So this precinct is used, all the people that voted at this, or that were registered, I should say, at this precinct in some census tracts had a very high census tract, which increased its odds of showing up in this weighted rank. And so here we see York County is the 25th percentile in the top 25, precinct ID 530001-1, and there was another one right on the first page in the 47th precinct,